Okay, in the last video, I mentioned that ABA may be an applied field, but it's still data-driven and focused on using interventions that are evidence-based. So in this video, we'll talk about research designs used by people in the field who want to know if an intervention is working or who want to compare two interventions or whatever. Now, earlier in the course, we talked about reversal designs as one common setup for studying single subject change over time. In that case, that meant starting with a baseline, then doing a treatment for a while, then reversing back to baseline for a while, then doing the treatment and repeating those reversals. We talked about it as a A-B, 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 A-B kind of design, depending on how many reversals you choose to do. And yes, I realize how obnoxious it is that there we used A and B to mean baseline and treatment, but now we're talking about the acronym ABA as applied behavior analysis, but it is what it is. At any rate, take a moment and maybe think through some of the potential downsides of using a reversal design. Like if you want to know whether a treatment works for some kid at a therapy clinic you're working at, why might a reversal design cause problems? Pause for a moment and think about that. Well, first there's the limitation we find with any single subject design that the small number of participants we study may not be representative, so we do need to replicate it in a wider variety of people and places just to be more confident about that. But that's also a problem with normal between subjects group designs, where we're comparing, tall people to short people on some personality trait, when all the tall people and short people in your study might still be coming from the local community or being a convenient sample of college students. So we have to worry about external validity with pretty much every study. That's not unique here. That said, I actually think this one is a little less of a limitation than it seems when we're talking about ABA, because a parent or a therapist or a BCBA using this intervention, they may not give a crap about whether the treatment works for all kids. They may just want to find out if it works for this kid. So for an applied situation like that, maybe we only care about the internal validity to know if the treatment works here and now, and we don't have to worry as much about the external validity, the generalization, unless we're trying to convince other people this is a treatment they should use too. But there are a couple more fundamental limitations or downsides to a reversal design if we're doing research. So first off, there's an ethical problem here. If the treatment is actually working and helping someone, then reversal means removing an effective treatment, which may mean increasing undesired behaviors, bringing them back to a condition where, they might be self-harming more or harming others or whatever it is. So doing the reversal, it'll help us confirm that it's genuinely the treatment that caused this improvement, but at the risk of this individual or these subjects potentially going through some harm when we go back to the baseline phases, just to get us that scientific info. For that matter, we briefly mentioned this before, but reversal designs are sometimes impossible. Like, if the treatment is long-lasting or causes permanent changes in behavior, then when we go back to baseline, the behavior won't change back, so our data will be kind of useless. We won't be able to confirm if the treatment caused the improvement or if something else that happened at that point in time did, like due to maturation or outside events in the subject's history at that time. So we need some alternatives to reversal designs if we're going to do single subject research in applied behavior analysis. And remember, single subject does not mean that we only use one participant, though we could do that. We'll likely use, a small number of participants with a ton of data points per participant. And we could theoretically do the same thing for 100 or 1,000 participants, and it would still be a single subject design if we're graphing and analyzing each participant's data separately. That's what makes it single subject, that each subject is analyzed individually and not pooled for statistical averages. Now, one research design that works really well for ABA is called an alternating treatments design. This is especially good if you want to kind of compare two different treatments. So here you might quickly alternate back and forth between different treatments. For example, you would randomize which treatment to do each day or each session. So like in this example here, we've got two participants graphed out. We've got Jimmy on the top, Sue graphed on the bottom. We're measuring how many positive statements they make. That's the behavior of interest, something we want to increase using one of a couple interventions we might try. But we don't know which intervention will work better. Maybe it's verbal praise for each positive statement. Maybe that's the best way to get them to make more positive statements. Or maybe using a token economy. So what we do is we first measure them at baseline for a while to see how many positive statements they're making currently. Jimmy's doing like 0 to 1 each day, while Sue's averaging around 2 to 3 each day. And in both cases, we've got a pretty clear flat trend at that level, right? Then, starting on day 8, we try one of the treatments, one of the interventions. We do verbal praise as a contingency. Every time they make a positive statement, they get praised. And once again, we're going to measure their positive statements. And yeah, not much change that first day, but obviously this is the first day experiencing that intervention. But then on day 9, the next day, we don't do the verbal praise anymore. Now we do the token economy. And once again, we measure their behavior across the session. On day 10, maybe we're back to verbal praise. On day 11, we do the token economy. On day 12, verbal praise, and so on. Now, it doesn't have to mean that we're switching every single day. We can randomize it or even pseudo-randomize it so it's not perfectly predictable. Like here, you can actually see a run of 2 verbal praise conditions and then 2 token conditions in a row. But the point is, after recording their behavior in these 2 conditions for a while, we can see from the line with small dots here that the token economy didn't change their behavior much. But that dashed line, yeah, it did get consistently higher and seems to have an upward trend now. By this point, we might decide that's the best option, that's our treatment now, and the behavior may keep going up until it reaches asymptote, as we're just doing now in the far right part of this chart. We might just be doing the verbal praise intervention now. Or here's another simplified example, just for one participant named Bob, but we're looking at, say, how many words per minute Bob is reading. So higher is better on the y-axis. We want more words per minute read. And we just have days on the x-axis here on the bottom. So excuse me, at baseline, Bob's been pretty consistently reading 25 or so words per minute. Then we start doing alternating treatments on September 17th and 18th and so on. Again, somewhat randomly, so sometimes there might be 2 blue days in a row or whatever, but each day we record the words per minute that he reads. Notice what we're finding here. The red line is getting maybe a little higher than baseline. It's hard to be sure whether that's a significant improvement or just noise. You know, if it stays up there a little longer, that means it's at a level consistently a little higher than anything we saw in baseline. But the difference between the red and the blue line is what's most important here. That's what tells us Bob's reading speed isn't just getting better over time, and that his reading speed isn't just a trait that he's at right now, but rather his reading speed is to some extent controlled by the contingencies at play. His reading speed is higher depending on what intervention is being done. So that intervention affects his reading behavior. We have evidence that it works, and that it works better than the second intervention in red. So again, that's an alternating treatments design. But it still runs into a problem that sometimes one of the treatments just maybe could cause so much permanent improvement that the other intervention looks similarly good as like a mere side effect. Like if the blue intervention here was raising Bob's skills overall in a trait-like manner rather than just controlling his behavior as an operant, then we would see red dots up around the same place as the blue dots at any given time, and it'd be hard to know which treatment was the one doing it. So there is a different class of research design that's even more popular in ABA studies, and these are all called multiple baseline designs. So multiple baseline designs are research designs that introduce the treatment at different times as a kind of fancy way of determining whether the treatment works. So we're just using one treatment here, one intervention that we have in mind, but we're going to try it at different times. There are 3 common varieties that we'll talk about. I'll go through each of these. So we could add the treatment at different times across different settings, like different contexts or places. We could add the treatment at different times across different participants, trying it with different people. Or we could add the treatment at different times across different behaviors. So the benefit is we're just adding the treatment, so there's never a reversal back to baseline. Excuse me. That makes it better than reversal designs. Helps with those issues we had both ethically and with the issue of long-lasting or permanent behavior changes. But as we'll see, the logic of these designs, they still have good internal validity for supporting conclusions about causation. So in other words, it can give us good evidence that a treatment is what's actually causing the behavior change. So let's talk about these 3 types of multiple baseline designs in turn. First, we'll talk about multiple baseline across settings. So imagine our client has some unhealthy behavior that we want to lower the rate of. For the first 5 days, we're just going to measure that behavior in all 3 of the settings. So in like the classroom, the cafeteria, and in the playground. So look at the x-axis here. We're just in those first 5 days on the left. And across those 5 days, we've got to measure at 3 different locations. So here's the key. We're going to start doing the treatment on day 6, but only in the classroom setting. Meanwhile, we're still measuring the behavior in the cafeteria and in the playground on day 6, but without the intervention starting there. Then maybe on day 9, we start doing the treatment in the cafeteria as well as the classroom, but still not doing it on the playground. We're just going to measure on the playground, right? We're still measuring behavior there during those days, but no treatment yet. Then we finally do the treatment in the last setting. And again, we keep observing the behavior across all 3 of those settings. So we're at this point at the 12 or 13 day mark or whatever. Now we're actually doing the treatment across all 3 contexts, and we continue measuring the behavior for a while to see where it levels off, where it goes to. So what we're looking for is this, like, does the behavior change only in the setting or settings where the treatment has been added so far? Like, that helps build the logic that it's indeed the treatment that's causing this behavior to decline. Imagine instead that on day 6 and 7 and 8, when we start the treatment in the classroom, what if the behavior goes down across all 3 of the settings? That would mean we don't know if the treatment caused that or if something else happened during those days which caused the change. But if it follows a pattern like we see here, then we got pretty good evidence the treatment was the cause, because we can basically rule out threats to internal validity like maturation, external history, or just general coincidence. So that's the power, the logic of the design. Here's a real example from a study in 2006. There was a 17-year-old high schooler who had developmental disabilities, and he was drooling a large amount, just constantly. Like, it got on school materials, soaked them through. Peers were avoiding him. It was causing distress and dysfunction. So the behavior of drooling was targeted with a treatment. In this case, the intervention was skills acquisition plus a DRO, differential reinforcement of other behavior, basically giving the kids favorite treats if you had dry mouth on a periodic 15-minute check by an aide, by a helper. So what we've got on the graph here then are 3 locations that they did this treatment at, 3 settings. So the main classroom, a community setting, and a cooking skills class for like activities of daily living. So first off, we're measuring the baseline number of saliva pools per hour across all of these settings. So that's the left part of the graph, the baseline, where the x-axis is just the 60 or so days throughout this whole study here, right? The left is our baseline days. In the first graph up top, we see the treatment was administered in the classroom setting on day 11 or so, and the drooling went down in the classroom, but not in the other settings. Then around day 21, the treatment was also applied in the community setting, right? So now we see that, again, the behavior goes down there. We're still measuring it in the cooking class. It's a kind of extended baseline for the cooking class, but we haven't started the treatment. But then eventually, finally, we start the treatment in the cooking class as well, at which point there it starts to lower as well. So by the end of this 2-month study, not only is the 17-year-old no longer drooling huge amounts, but we've got evidence that the skills acquisition plus DRO treatment we used is what caused that change. So maybe we want to try the same thing with others who have a similar problem and see if this replicates. Anyway, that design, that's multiple baseline across settings. Then there's multiple baseline across subjects, where for different subjects you apply the treatment at different times. Like in the graph here, we're measuring 3 different people during baseline. Then after 5 sessions, we might start the intervention with person A, but hold off and just keep measuring baseline for persons B and C. Then later we started with person B, still doing it with person A, but we're holding off on person C a little while longer. Again, the key question here will be, does the behavior change when and only when the participant gets the treatment, when each individual participant gets the treatment? If it goes down for subject C before we even start treating subject C, then something's up, and it's probably not the treatment, right? But if it looks like the graph here, where behavior suddenly improves when and only when we start the treatment for a given subject, and we see that across multiple subjects, now we're starting to build evidence that's the treatment that does this behavior change. Notice the logic here. Like if we see a pattern of data like what's on the left here, something weird is going on. If these are 3 kids from the same school, maybe some other school program started around day 6 or day 7, some other intervention. Maybe something was in the news that week and it affected all 3 of them. Maybe the school cafeteria they all go to made a big change in the ingredients that are used. So the data on the left isn't very convincing, but if we see data like that on the right, then it tells us like probably, right, we can be more confident that contingencies of our treatment are what are controlling the behavior, what's causing the increase. So we've got internal validity. Here's an example with 3 participants. So Ariel, Jonah, and Susanna, the 3 graphs here, where they did a multiple baseline across subjects design just to treat challenging behaviors, like challenging the instructor or the therapist. So each of the subjects was doing like 30 to 70 challenging behaviors per session during baseline, quite a lot. Then we start the treatment for each of them. We're going to start it on a different session. So we'll measure all of them the whole time through the whole experiment. And sure enough, we see the challenging behaviors go down when we start our treatment. But notice behaviors only decrease for each subject when the treatment, in this case pairing was the treatment they used, when that's applied to the subject. So just FYI, the little dot at the top of the graph for Ariel, that says surgery. That's just making a note there was an outlier day with lots of challenging behaviors, but likely because Ariel had just had surgery right before that. Anyway, one other thing to point out in the graph here is notice there's a big dotted line going down the graph after session 13. At the end on session 14, they tested during a novel task to see if the treatment generalized to other situations, which it did seem to. And for Ariel, the graph actually also lists a follow-up data point so the researchers might report like whether the improvement stuck after some time had passed without the treatment. So somewhere in the figure caption or text, they tell you how much later this follow-up was, like if it's a 2-week follow-up or a 6-month follow-up or whatever. And of course, if we do each of these phases longer, if we do more follow-ups and everything, we would of course get stronger evidence. But often in an applied setting, you've got a cost-benefit analysis going on. So this is the real world, applying an intervention to real people, not rats. And it can take time and money, or there can be opportunity costs by like taking the kid out where they could be doing some other activity, right? So we don't necessarily want to do these interventions for 6 months. If we can get pretty good data, kind of satisfice with good enough data that we think things worked after just, 14 sessions or so. Now, here's a real world study from 2005 where they used a multiple baseline across subjects design, in this case to teach firearm safety to preschoolers, like if they run into a gun at home or at school. So you may not know the stats, but a lot of little kids die each year by getting a hold of their parents' gun that isn't locked up safely. So here we've got just an educational intervention to teach kids how to behave when they come across a gun. In this case, the y-axis is a simple rating scale they came up with of what behavior the kids do when they come across a gun. So 0 means the kid touches the gun, like they pick it up or start playing with it. 1 means they don't touch the gun, that's better. 2 means they leave the area. And 3 means the preschooler leaves and tells an adult about the gun. So presumably for safety training, we want them to get higher on this little behavior scale, right? Now, we've got 10 preschoolers here that we're going to give this training intervention to and see if it works, see if there's evidence for the intervention by using a multiple baseline across subjects design. That means we're measuring everyone's baseline behavior the first couple days. Then we give the treatment to 3 of them, but we'll keep measuring the baseline behavior for the other 7 kids. Then the next day, maybe we give the treatment to 3 more kids, but keep measuring everyone, including the 4 still in baseline. Then we give 3 more kids the treatment, and then we'll finally give the last kid the treatment. Notice in general here, the improvement only happens to a kid once they've received the treatment. So we've got pretty decent evidence here that our treatment works. And there's a little footnote at the bottom here that the last data point for each participant is actually a 3-month follow-up assessment, meaning 3 months after the intervention. We're no longer doing the training, just 3 months later, seeing if they're still doing the behavior, if it was lasting. That's why the last dot in some of these graphs is separated from the main line. So it's not misleading because that's actually 3 months later. Now, here's one last example for a multiple baseline across subjects design. There's a treatment often used in smoking called contingency management, where they'll set up a contingency to give a person like vouchers, in this case Amazon gift cards, as reinforcement for lower rates of smoking, or eventually to reinforce no smoking at all, total abstinence. So in this 2005 study by Dallery and Glenn, they used at-home carbon monoxide test kits that were just reported over the internet rather than having expensive in-person therapy. And they're seeing if this voucher reinforcement contingency works across the 4 participants that we see labeled here with numbers like C0037 or P0038. Those are the participants. So on the left side of the graph, we've got the usual baseline measure first of CO levels, right? Higher means they've been doing more smoking. Then at different time points, each subject is going to enter treatment. They're going to enter what they called the shaping phase. So the next chunk of each graph, just to the right of baseline for each person, that's the shaping phase. Here they were given vouchers contingent on successfully lowering their CO levels. Basically, it's shaping them to smoke less. And we know the formal term here would be DRL, differential reinforcement of lower rates of behavior. They get a gift card if they smoke less than before. And then this study goes further and does another phase. So the second phase of intervention, the next chunk of the graph, again, at different times for each subject, so we can tell whether that's what's causing things. But now they're going to go to an abstinence induction phase. So total abstinence, where subjects were given gift cards only for abstinence, which is defined as the dotted line here as a CO level of less than 4. That's considered not smoking. Then they did do another phase labeled thinning, where the reinforcement, that's like the monetary amount of the vouchers or how many vouchers you can get, was thinned out. Basically giving less of a reward for abstinence each time, but they're still getting a reward. It's just more occasional or not as much. This is important because obviously we can't keep paying people forever just to not smoke. Finally here, they also did go back to baseline at the end. So they did do one reversal at the end here just to see if the treatment stuck when there's no voucher anymore. Basically, they wanted to know whether there was a lasting decrease in smoking, even when they're not in the program anymore. And we can see, if you go down to the second graph, for the second subject, it definitely seemed to last long term, right? Even when they're no longer getting the vouchers, when contingency management is no longer being used. For the third subject down, it's definitely way lower than baseline, right? It did seem to go up a bit when the contingency management treatment went away, but still, this person has improved. For the bottom subject, there's definitely more noise and variation. It's a little less clear, but there is more abstinence than not in the final phase, which almost never happened back in baseline. So that does seem to be an improvement, even when we're no longer doing the treatment anymore. And then there's that top subject, C0037. There they did note in the article that person had a major family issue early in the abstinence period, hence why things shot back up and the treatment may not have stuck very well for that person. But anyway, that's a real world example of multiple baseline across subjects. But then there is one last type of multiple baseline design, which is multiple baseline across behaviors. So in this one, we're going to basically check if a treatment works by applying it first to target one behavior, and then use the same intervention but to target a different behavior, and then maybe another one, and so on. So we could do this for 4 or 5 or however many behaviors we want. But again, we're applying the treatment across behaviors at different times. So, for example, if we want to test an intervention that involves giving stickers as a reinforcer contingent on a desired behavior, then we'd measure a few different behaviors for a while as a baseline, right? Then on day 4, maybe, we start giving the sticker anytime they do the hand-raising behavior, right? If that's our first behavior. So we've got a contingency of hand-raising leads to a sticker. And we can see from the top graph here, hand-raising does increase after that contingency is added. But later we might start giving stickers for reading behavior. So that's the middle graph there. And once the contingency starts for that behavior, then that behavior goes up, even though the third behavior of sharing hasn't gone up yet. But finally, when we start giving stickers contingent on sharing behavior after day 10, we see sharing behavior in the bottom graph starts to go up as well. Boom. That's multiple baseline across behaviors now. Same logic. Or a very simplified, silly example of this could be done to target some kids' problem behaviors in like a first grade classroom. Maybe the kid's been out of his seat running around a lot. He's been yelling. He's been fake crying. And he's been making fart noises with his hand in his armpit. These are all, distracting to the other students, and he's failing his work because he's not on task. So the teacher might come up with an intervention to try to use on each of these behaviors starting on different days, right? So we can tell whether it's the intervention that's actually changing the behaviors. And this is going to be a made up silly example. So let's say the teacher's intervention is to tackle the kid while making football announcer sounds anytime the kid does a target behavior. Well, okay. Here's how this would work with a multiple baseline across behaviors. What we do is on the first 5 days, we've got to get a baseline. We're just going to measure all 4 behaviors, but not tackling the kid yet, right? They do the behavior, doesn't matter. Then on day 6, we introduce a contingency for 1 behavior. We start tackling the kid for running around behavior, but we're still just measuring the other 3 behaviors. No contingency attached to those. Then on day 11, we're now going to tackle him contingent on running around or on yelling behavior, just not the other 2 behaviors. By day 16, the contingency also applies to crying, fake crying, so now 3 behaviors. And by day 21, we're applying the treatment to all 4 behaviors. And of course, this entire month, we're measuring all 4 behaviors the whole time to see if our unethical, silly intervention works, right? That would be a multiple baseline across behaviors design, though I definitely do not recommend using tackling as an intervention. Okay, here's another example applying the idea. Imagine we've got a young student struggling in math class. So we've got an idea for an intervention, maybe based on the literature. We think this intervention will work, will help improve performance, get the kids solving many more math problems during a session, not giving up, right? So initially we spend 5 sessions just measuring how many addition problems he gets correct each session, how many subtraction problems, and how many multiplication problems. That's our baseline. The numbers are maybe a little lower than we might expect or hope for his age group or how much training he's had. So we do our intervention, whatever the intervention is that we think works, right? We do our intervention, but initially just for addition problems. Maybe it's using verbal praise, like saying, good job, every time he gets one right. Or maybe our intervention is a token economy, and every 10 math problems he gets correct gives him a little piece of candy that he likes. Whatever it is, we do this intervention only for addition problems. Then later, we'll also do it for subtraction problems. Then later, we'll also do it for multiplication problems. Notice that the student's doing subtraction and multiplication problems the entire time. So we have baseline data and continued measurement for those behaviors even before the treatment applies to them. And we can see, if we see data like this, where the behavior only goes up when we introduce the intervention, then we have evidence that it's the intervention that changes behavior. The intervention works. It helps people. A real-life example of multiple baseline across behaviors can be seen in this graph from a 2002 study with a kid who had what they described as extreme food phobia. But probably we'd now call it avoidant restrictive food intake disorder, ARFID. It's a type of eating disorder. Anyway, this was really messing with the kid's health. He had been literally eating only water and protein drinks for years. So as an intervention, they first targeted the behavior of drinking other fluid, like juice, something he would never do otherwise. And the intervention they used was modeling plus contingency management. And you can see from the top graph here that he went from 0 servings of other fluids on the first couple weeks to consistently being able to drink other fluids across the next 25 weeks. And even in the 2-month follow-up and the 6-month follow-up, after they stopped doing the intervention, after they're no longer doing the intervention at follow-up, months later, it had stuck, right? It's still working. But notice they waited until week 5 to start using the same intervention to target a new behavior. This time they targeted the behavior of eating soft foods. So they had been measuring that behavior already. And obviously, he was at 0 during the first 4 weeks. He never ate soft foods. He had never done so before. But once they introduced the treatment, wow, the behavior went up, right? That's the longer line that you can see here, the one with diamonds. Now you will notice a second line was added on the graph for just part of it using triangles. That was actually graphing out a second behavior, is vomiting behavior that he started doing. Started happening with soft foods around week 7. And then on week 12, they kept doing the original intervention of modeling plus contingency management. So the original intervention is still happening to get him to eat soft foods. But you can see the little note here that at week 12, they also added a new contingency for vomiting behavior. They did an intervention of timeout and reintroduction of food after he vomited. Basically, they realized vomiting was an operant behavior that was under his control here. He was doing it kind of on purpose, right? Or he controlled it in any way. And so he was choosing to do the vomiting. Sure enough, once they did this, negative punishment of a timeout period, the treatment here, the vomiting behavior went immediately down to 0. And he kept eating soft food, something he had never done before. And at 2 months and 6 months follow-up, sure enough, still eating soft foods. His behavior had changed. His eating disorder is getting better. If you go to the third graph down, you can see hard foods, where again, he wouldn't try any until they introduced the treatment for it on week 14, after which suddenly he's eating hard foods pretty consistently, again, even months after the intervention had stopped. And in the bottom graph, we see the same thing for chewy foods. So this was a real life example of a multiple baseline design showing that modeling plus contingency management worked to get a little kid like this eating foods that he had refused for years to the extreme detriment of his health. All right, that's enough about research designs for ABA. There are, of course, other designs and subtle variations on these. And of course, you can add complications or extra phases along the way, as we saw in some of those, like the smoking one. But the basic logic remains the same. We're finding a way to introduce the treatment at different time points in order to rule out confounds. That allows us to increase internal validity and be more confident the treatment genuinely changes behavior. If it does, it's working for the person or people we're working with. Awesome. And if it consistently works when we try replicating it with others, we may start to assume it's an effective treatment in general, right? Or more people can try it with their clients or patients or students or pets or whatever. And of course, the whole time, these interventions we're testing don't just come from nowhere. We're not just trying out some random intuition we had. We're basing it off of the published research literature coming out of the experimental analysis of behavior and all the principles we learn in courses like this. Anyway, in the next video, I actually want to talk a little about how behavior analysis influences therapy, and then we'll see some other applications of ABA outside of working with kids or therapy or people with developmental disabilities. Then we'll finish up with a video on applied behavior analysis used in animal training, which is another really common ABA field.